Hello everyone, it's January the 8th. Alright, let's get on to business. Wow, 3 in a row. Counting words with a given prefix. We are given an array of strings and then a string prefix. Return the number of string that contains prefix. Alright. I think we need to do the try at least once, so let's do the try today then. Alright, try node. Want to define a class. Well, I think I have we can do try node children 26, and then boolean end of word. I forgot how to define a class. Constructor. Initial value. What if I don't have an initial value? I don't have any initial value. Actually, I don't know how this one works. Probably no. Alright, I need to check yesterday's problem. Yesterday's problem has a example of try node. Equal to this. Not equal to no. Okay. So we don't need this. Oh, is that bool? Okay, so we can say try node root. Right, we define try node root, and then we say for string word in words try node equal to root for, I'm not sure. If, let's say, dot children, right? Oh, we define a pointer to root. Why is it not working? Because I need to define these as public. Yeah. So children C minus A. If it's equal to null, okay, then node children C minus A is equal to, how do we do that? New node. Using new. But we don't have a constructor. I guess it's fine, right? So I do think I need to have, maybe say, a try node. Probably this is good enough. Because I don't have, how to do empty constructor, right? Public, just do that. Wait, how about an empty constructor? I forgot all this empty and default and stuff. Okay, this is the empty constructor. Okay, empty constructor, I need to have this. All right, so that's the constructor. And how about this one? Do we do how do we create a new node? No, we just it directly create, but it create, this is a try, and inside is a node. New node. So I just define it, right? So I should say this equal to new try node. Okay. And then this is fine. Right? And then we say will equal to new try node. Yeah. And then node equals to node children C minus A. Man, first time doing try in C++ is very, very wonky. Very wonky. All right, once we're done, then we say end of word, it should be true. Okay, default is false, right? Actually, I think there is something I can do. For example, end of word, we set it to false. No, I think it'd be this. All right, end of word, we set it to false. So yeah, so this is to create the try. Create the try. And then we'll go consume the try. Wait, what's the problem? I forgot the problem. Count words with given prefix. Okay, so we have int res equal to 0. For string word of words. Okay. Now we just need to compare prefix. So actually no. I have created. Hold a second. I have created a try based on the words. Now you just need to go prefix and see the counter. I just need a counter. Okay, so It's gonna be int count, my bad. Okay, now we set count equal to 0. Yeah. And then every time that I do something, right? So basically I need to know the count. So we added a node, we encounter a character, and then we move on to the node that is represented by the character. So I think here is where we say node count plus plus. So we don't even need this. Okay, that's not what we're interested in. We just keep the counter, and we don't even need this. We don't need this. All we need to do is just redo it, right? Query the trie, right, for the count of prefix. So we do trie node again. That's gonna be a pointer to the root, right? And then for char c of prefix, because we need to keep going until, oh, it has to be the entire thing, right? So basically, if something doesn't include, then we should just return 0. So we say if node children c minus a is equal to null, then we just return 0 immediately. Otherwise, node equal to node children c minus a. Right, so we keep going, and then we'll return node count. What the hell? I think we need this. Okay. Yeah. Try it, and we're gonna write something here. Use trie. Two 185. Use trie. This is, I think, the first time that I have implemented a trie in C++. Lang words n is and prefix. Okay, we're good. One more time. Submit it. Oh, I solved this one before. Old problem. 31.5%. Of course, because we know what is the easy, faster way. Let's also do the faster way, which I believe we have contains, right? Or find. This should be a faster solution. Let's see how much faster. 6 milliseconds. There's even faster one. 0 milliseconds. 6 milliseconds. I don't know. I mean, we could just check it one by one. Whatever. Brute force built-in method starts with try. No, this is just a practice try. It's not because of anything. It's just a practice. Don't think of it as in any, like, try is better than the other one. No, it's not. Right? It's not always the case, but you need to practice. You can't just like read some tutorial how to do try and then say, yes, I know how to set up a try. No, it doesn't work that way. All right, a task manager that allows users to manage their tasks, each associated with a priority. The system should efficiently handle adding, modifying, executing, and removing tasks. When implement the task manager class, well, this initializes the task with a list of user task priority triples. Each element in the input list is of the form user ID, task ID, and priority, which adds a task to the specified user with a given priority. So add a task to the user with a given priority. Adds a specific to the user with user ID. It's guaranteed the task ID does not exist in the system, so we'll always add a new one. Edit will change its priority. It's guaranteed that it exists in the system. Must we remove a task identified by task ID? Executes the task with the highest priority across all users if there are multiple tasks with the same highest priority. Execute the one with the highest task ID. After executing, the XID is removed from the system. Return the user ID associated with the task executed. If no task available, return -1. A user may be assigned multiple tasks. So we have user ID, task ID. I think dictionary is the best. Right, you can say map for the C++. Actually, I don't want to use C++ to solve this, unless you want to do priority queue in C++. Actually, I should. I don't think I've done priority queue in C++. Okay, we'll do C++. So basically, it's just a map, right, with user ID as an int. Right? So with user ID as the key and a priority queue as a value. And the priority queue will be based on two things. The first is the priority. I think I've done priority queue before in C++. So it'll be the priority will be the first one to compare, and the task ID will be the second one. And this method will have one issue, which is add is fine. We just add a new one into it. Edit. That's the edit. I guess it's fine. We maintain another. So two maps. One map will be handling the user side, and the other will be just keep track of the task ID, and then it's a new priority, right? It's new priority. So every time we edit, we have to put a new one in the priority queue as well. Oh, hold a second. When you add, you get task ID. When you edit of the existing task ID to new priority. So multiple user is also possible that multiple user will, I don't know, multiple users with the highest priority across all users. So across all users. So that's a different design. So task ID, so the priority queue will be priority and task ID. And we have another one to keep track of priority and task ID, right? So when you edit, that's fine. We push a new one in, and then when pop from the top, if it's different, we just pop. Just like Dijkstra. And we need user ID as well. So the task ID. So task ID points to priority and the user ID, both, right? So when a task ID gets executed, no, gets removed from the, so if the task ID is removed, then we just remove, yeah, okay, so I think I know how to do this. I don't want to do it today. All right, I'll see you guys tomorrow. Adios.